This is section 7.6. We're going to talk about inverse trig functions here. This can get a little bit complicated. Hopefully it won't be too bad. But what I want to stress is that everything we do at the beginning here where we're talking about domain and range, I know that many of you struggle with domain and range, but what we need to make sure is that this is important. This really is important for you to understand this, and you'll kind of see that as we go through this section. So let's talk about domain and range real briefly. So domain, recall, is the input value, the x value, the theta value. It's what you're inputting. In other words, is there any limitation to what we can put in? For sine, there isn't, so we can say that that is all real numbers, and I just always say ARN for all real numbers. The range is the output. Based on what we put into the function, what is possible for the output. And hopefully you recall that all of our sine functions, they go in between -1 and +1. So our y is always going to be from -1 to +1. And the same thing is true actually for our cosine function. Our domain is all real numbers, and our range goes from -1 to +1. With tangent, it's a little bit different. Our range, if you recall the graph that we showed for the range, those actually go all the way up and all the way down, so those are all real numbers. But because tangent is the sine over the cosine, we had to figure out where cosine was equal to 0 because that's what makes it undefined. And so when we graph that, we figure out that the cosine is equal to 0 at pi halves, and then every pi after that. So therefore, we say that it's all real numbers, but we have to have a little portion where, not x, we're going to call it theta. So theta cannot equal pi halves plus pi times n. Okay, that just means that it can't be equal to pi halves, and then it can't be equal to every pi after that. So pi halves plus pi halves plus 2 pi halves plus 3 pi, etc. Okay, so that was where all of our asymptotes came in. So now that's not going to be hugely important, but it will be important a little bit for how we come up with the domain and range for the inverse function. So now we're talking about the inverse sine, and we've dealt with this a little bit in chapter 9 about how we use these, but basically if you recall, inverse just means you're switching your x and y values. So that is somewhat true for the domain and range here, at least for the parts of the range going to the domain. So now instead of the range being -1 to y to +1, the domain is going to be that. So it'll be -1 is less than or equal to theta, which is less than or equal to 1. The difference is with range, this is where it changes a little bit. It is not going to be all real numbers. We have limitations here. And our limitations are that the inverse sine function is going to go from -pi halves to +pi halves. What does that mean? Well, if you're looking at a unit circle, recall that pi halves is up here and -pi halves is down here. So that means that a inverse sine function will only be defined on this side of the circle. Okay, so it will not be defined anywhere else, either negative backwards or positive forwards to pi halves. So the domain for cosine, inverse cosine, that is still going to be -1 is less than or equal to theta, which is less than or equal to 1. So that's in between -1 and 1. In the range here, it changes again, but it's not the same as this one. This is where it gets a little bit tricky. This is going to go from 0 to pi. In other words, for this one, it's only going to be defined on the top half of the circle. And then we go to tangent, and the domain, of course, is the same as the range above, so that's all real numbers. And then our range here is going to also be the same as it is for the sine. It's going to be -pi halves is less than or equal to y, which is less than or equal to pi halves. So again, that is going to be on the right hand of the circle as well. And this is going to be important because what we're going to want to do is we're going to want to be able to identify which quadrant we're going to be in. Okay? So the first thing is, let's get into the first set of examples here. And I apologize if this video is going to be a little bit longer, but we are going to spend a couple of days on this, so it'll be one long video and then you won't have a video for a while. So the first thing is okay, without a calculator, we want to find the value of the inverse tangent of -1. Well, this can be a little bit tricky. The first thing that we want to understand is that let's first identify what the range is. What is the possible values that we can get? And we just said that it would have to be in between -pi-halves and +pi-halves. So what that means is when I draw my triangle, I know that it either has to be in the bottom right quadrant or the top right quadrant. Well, if we're dealing with a negative number, it's going to have to be in the bottom right. So what I want you to think about is I want you to think about drawing a right triangle in the bottom right quadrant. So what we're thinking about here is we're at -1. Well, that means that our tangent, if the inverse tangent of -1, if we're trying to find that, then that essentially means that we are saying the tangent of theta will equal -1. In other words, we are just switching our values because that's what the inverses do. So the inverse tangent of -1 is the same thing as saying the tangent of theta equals -1. And then what I'm going to do is, because we want to turn it into a ratio, I'm going to put it over 1. So what's going to happen is we are going to say that the legs of our right triangle, remember, tangent is opposite over adjacent. Opposite over adjacent. So therefore, our -1 goes right here, and our adjacent is going to be right here. So we have 1 and 1 as our triangle. Now, if you recall, from geometry, if we have the same sides of a triangle, then that means the angles have to be the same, which means this is going to actually be a 45-degree angle. Again, I know that because this would have to be a 45, 45, 90 because these two legs are the exact same. So how can we answer this question? Real simple. All we're going to do is transfer this to radians. Notice it is negative, so 45 degrees is equal to pi-fourths. And because it is on the bottom half, it would be negative. So that's what our answer is here. This is a little bit more of a complicated problem than this one is. So let's talk about the sine one. We have the inverse sine of -1/2. Again, because it's the inverse sine of -1/2, we are essentially saying what will theta equal. Sine of theta equals -1/2. Once again, we want to identify what our domain and range is. So we know our answer has to be somewhere in between -pi-halves and +pi-halves. So once again, because it's negative, it's going to be in the bottom right quadrant. So we draw our right triangle, terrible right triangle again, and what we do is we label it. So we have -1 here, we have 2 here, which means we should be familiar with this triangle, which means this is going to be the square root of 3. So now we can identify that the angle here is going to have to be a 30-degree angle because that's what's opposite of our -1. So we can now identify that our angle is going to be -30, and if we take -30 degrees and we transfer that to radians, that's going to be -pi/6. Okay, and that's really what you're doing is you want to be able to first identify where the triangle will be, then identify the angle of what that triangle will be, and then you're going to convert it into radians at the end. Okay, so you have one down here to try on your own. So try and use the examples from above and what we did and see if you can get that, and we will see how you do. Okay, so for this one, hopefully you got, first of all, you had to identify that your range here was going to be from 0 to pi because it's cosine. So because of that, the positive value would give it to we would want the positive value in the top right quadrant. So what we did was we labeled our right triangle. The adjacent side is square root of 2. The hypotenuse side is 2. So that means that we have a 45-degree angle. It would have to be a 45-45 triangle. And then we transfer that 45 degrees to be pi/4 in radians. Okay, so hopefully those problems make sense. Let's move on to the back side. Okay, these ones are going to be along the same lines, maybe a little bit more difficult at first, but then when you kind of see what we're doing, you'll see that this isn't that big of a deal. So we want to figure out what the tangent of the sine, inverse sine of -1/2 is. So basically, what we're going to start with is we're going to think about our inverse sine. We first of all know that this is going to have to be -pi/2 to +pi/2. Now, the only reason why we need to identify that is we want to know which quadrant it's going to be in. And because it's negative, it's going to be a fourth quadrant. So basically, this is how easy this is going to turn into. First, identify the quadrant. So we're going to be in the fourth quadrant because it's negative 1/2 that we want. And then we're going to label the sides. So it'll be negative 1 is this side, 2 is this side, which means square root of 3 is going to be this side. So honestly here, we don't really care in these problems, we don't care what our theta is. All I care is that this right here is our theta. It's got to be tangent of an angle. So what I've just done is I've created a right triangle with all three sides. So really all I need to find from here is once I've figured out where my triangle is and what all the sides are, now I just need to figure out what the tangent of theta is. Well, the tangent of theta is going to be negative 1 opposite over adjacent, and then we rationalize our denominator to be multiplied by square root of 3 over square root of 3. So we end up with tangent of theta, or this whole value is going to just be negative square root of 3 over 3. So these can actually be a little bit easier. You're first figuring out which quadrant you're in. Then you are labeling all three sides of your triangle. Once you have all three sides of your triangle, the inside part is meaningless. The only reason why we use it was to figure out what the three sides of the triangle are. Then we can just figure out what the trig function on the outside is. So go ahead and try this one on your own. Hopefully from the one above, this one should be fairly easy as well, so try that. In this problem, you had cosine, which means that our range had to be from 0 to pi. So because the square root of 3 over 2 was positive, we knew it was going to be a first quadrant. So because it's a first quadrant, I said square root of 3 is our adjacent, 2 is our hypotenuse, which means 1 has to be our opposite. So now that we have all three sides, we can set up the sine of theta is just simply opposite over hypotenuse, so it's just 1/2. So hopefully you got that. Keep in mind that if these were not special right triangles, if you didn't just know it, you would have to use the Pythagorean theorem to figure out what the third side is. But these ones were all set up in a pretty easy way. We'll work on this a little bit more in class. Hope that it makes sense. I will see you then.